Hello everyone, welcome back. I hope you're doing great. So in today's video, we will be going to do an exciting project that will be related to Docker because learning Kubernetes is very important, but you also need to know how things works when you have to deploy the application on Docker. So if you have seen my previous video, so I've also shown you that how can you deploy your three-tier application using Docker and Docker Compose. So in that video, we just simply use a self-managed Docker. And in today's video, my aim is to explain or show you that how can we deploy our applications on ECS. Now, first of all, what is exactly ECS? So ECS is a service from AWS, that is Elastic Container Service, and everyone, like every cloud, has its own service related to containerized applications, and you can deploy your applications on containers. So in Azure, they have their own ECS service. Like the naming convention is different, but the concept is same. But the point is that there are a lot of issues in ECS. That's why they choose Kubernetes to deploy their applications. But a lot of organizations, like if I have to choose that 20% of the organizations are still on ECS. Now, why they are using ECS? So we don't have to say that they are using ECS. We need to say that they're using container service where they are just deploying their applications on containers, like in a microservice based architecture. And maybe you can say that, Aman, if they're using ECS, so why are not they going with other Kubernetes clusters? Like they can deploy their applications on Kubernetes clusters. So the point is that when you have to work on Kubernetes, so you need to know a lot of knowledge. You need to have a lot of knowledge where you have to think about the scaling, networking, DNS configurations, your infrastructure as well, and a lot of things. But when you are using ECS, you don't have to worry at all about infra. Even there is a rollback strategy automatically there. There are a lot of functionality provided by cloud providers itself because they are managing the product, they are building the product, which is ECS on their own. So all the managed thing from their side. But when we talk about Kubernetes, so Kubernetes is from Google, but we know that it's an open source tool and it's heavily worked when your application is needs a lot of scaling, needs to know how to orchestrate the containers or how to play with the containers. But when you have limited number of containers, so you don't have to use Kubernetes because it's not good to jump on Kubernetes directly. A lot of folks, what they used to do, like whenever they understand that, okay, I have 10 microservices, so I should go to Kubernetes cluster. So no, that's not the real truth. The point is that you need to understand what are the things that you require to go for Kubernetes cluster instead of simply you can deploy your applications on containers like ECS service. So I'm not doing any advocacy here about ECS. My point is that a lot of organizations are using ECS or container service still in the market. They don't have enough traffic, or they might have some reasons like they don't want to migrate. And other organizations, those choose ECS or container service few years back. So they don't want to migrate because all obviously their applications is running fine and they don't want to touch. And when we have to do a migration for the big applications or the stable applications, so it takes a lot of time. It takes a lot of costing, R&D, POCs. A lot of things needs to be done. So it's very important that we need to learn. Like maybe you will get a job role where they are working on something where they have the ECS stack instead of Kubernetes cluster. So sometimes maybe you feel overwhelmed or you feel disappointed that, okay, I don't want to work on ECS. So if you're thinking as a platform engineer, then you don't have to worry about the platforms, because when you're thinking as a platform engineer, your first understanding is to how to work in multiple things or with multiple products. So if they're deploying their applications on serverless model like Lambda functions, API gateway, NoSQL or something like that, so you are not going to say that, okay, I need Kubernetes only. No, that's not you're going to say. Maybe I can understand you want to be in that comfort zone, but the important thing that you have to think as a platform engineer. That's where it will help you to grow yourself so you can work on multiple stacks. If you're thinking that Kubernetes is enough, I can say that Kubernetes is very difficult. It's not easy. It's not a cup of tea. But there is very important thing that we have to understand, that there is a difference between infra engineer and platform engineer or DevOps engineer. So your goal is to provide a solution that is compatible according to the requirement of the application. So if my application doesn't need any scaling, why would I go for the Kubernetes? Because Kubernetes is awesome. But the point is, when you're going to use Kubernetes, it comes with a lot of issues. Like it comes with a lot of tools. Like if you have multiple applications, you might have to enable the service mesh, like encryptions at that moment. So you will have the control over the containers, over the pods in Kubernetes, but you need to know what are the things. You need to understand how you can upgrade your Kubernetes cluster. In ECS, you don't have to upgrade any clusters at all, right? It will be going to play with the task definition, services, deployments, that's it. But in Kubernetes, you will have HPA, you can have VPA, secrets, config maps, and a lot of things apart from deployments. So that's about this ECS. I have an intention to explain you what are the differences so you can, when you worked on multiple tools, then you will be able to evaluate that, okay, which tool is good for your organization or good for your project. So that's you have to take the ownership or accountability for the desired project. So this is the introduction that I may be a little bit a difference between Kubernetes and ECS, but I will be also talking a little bit more about ECS. So I'll just show you a few things before telling you the ECS, I would like to show you about the application. So again, it's a three-tier application, and we have most of the time we have a same application. I don't want to invest a lot of time about the application because it doesn't matter to me. The main thing is that stack. So if the application is based on Java, Node.js, or any other, so I have to write the things accordingly. That's it. Apart from that, I just need to know how things works, how to configure the networking part, how to work as a infra engineer first, then we will have to work as a platform engineer to deploy the things over the server. So it can be Lambda, it can be Kubernetes, it can be container service. So yeah, like priorly we also understand how to work with EC2s, where we have deployed our applications on two-tier architecture. Then we will be going to cover three-tier architecture as well in the upcoming videos. But I wanted to show you the multiple ways to deploy a three-tier application. So that's where you understand what are the things, what are the pros and cons of a particular tool. So this is the application that as I've told you, and yep, like this is the application. Earlier, if I talk about the two-tier, so for that we have a dedicated branch which was two-tier test. Then for this, I've created a dedicated separate branch for this, which is ECS deployment. So feel free to, like, whenever you're going to use you use this repository. So please make sure you should switch to ECS deployment, because you are not going to get enough code, because I also made some changes in the code base because of some desired requirements. So I did that according to the application. So feel free to use this branch, and there we will have multiple things. And that's we have already discussed how can we deploy our application. So I'll just give you a very brief whenever we will be going to talk about the coding, Docker files, or workflow. So this is also end-to-end DevOps ECS project, where how things deployed or applications deployed in production ready ECS cluster, not EKS cluster. So we will be going to see that thing as well. So if I just go to the, here, so you can see here we have ECS cluster. And I am like, again, I'm not sure whether you have seen this or not, but if not, I would highly recommend you to do this project. And I make sure that whenever there is any project, any questions related to ECS, you will be able to crack it easily. Like it's not a big task. It's very few things you have to keep in your mind, like 4 to 5 things that I can say. And once you will get to know, that would be enough. Okay. So we will be going to talk about how to configure each and everything. So the first thing that I would like to say that this project is like where we will be going to use GitHub Actions. Then we will be going to use AWS, obviously, where we have our ECS cluster, and then we will be going to deploy our applications on ECS cluster. Uh, there would be multiple services that we will be going to use. So for the database, we are going to use RDS, and for the front end and back end, we will have ECS clusters where we will be going to deploy our containers. So that is it. And for to storing or keeping the Docker images, I will be going to use ECR, which is a AWS service. So that is an Elastic Container Registry. So that will be going to do as well. And if I talk about costing, so it doesn't occur more than $4 to $5, to be honest. If you complete this project within 4 to 5 hours or maximum 10 hours, so it won't cost you a lot, because we have very basic applications and it won't take a lot of time. Okay. So I would recommend you to complete the video or complete the hands-on. If you're doing the hands-on along with me, so I would recommend you to do this project along with me, so you don't have to wait and your services won't be going to run for a long period of time. So yeah, that is about the brief introduction about this, and let's get started. And as I told you, we will be going to create things manually from AWS, which is click ops that I can say. And we have to make sure that this can be achieved via Terraform as well. But today I want you to show how things works first with AWS console itself. Then you will understand what are the required things that you have to configure using Terraform. So let's start it. So the first thing, as usual, we used to do that we have to create our networking infra first. And for that, I will just go to the VPC section. Like I've already opened it. So here is our VPC section, and currently it's a default VPC. So I would like to create my own networking things. So I'll click on create, and I will go simply with VPC and mode. So it will be easy for me. Like what are the things I have to create? I'll provide the name is project ECS, and this is the CIDR block. I'll keep it. After that, this would be easy. The easies will keep it to number of subnets. Two would be enough for us. Then private subnets. It's very important for our project that we have to use private subnets a lot. Then this would be our net gateway. And yeah, there are multiple things you can use. Either you can go with endpoints for the services interaction, but currently I'm not going to use it. But if you think we are good with endpoints a lot, because if I'm going to do it, so you need a lot of, we need a lot of time for that. So currently I'm just keeping it simple, and the net gateway would be, I'll keep it zonal instead of regional, so it will cost me less. Then this is the net gateway, and then this is the VPC endpoint. I will be going to turn it off for now. Then apart from that, let's see what are the things that we have to do. Okay, amazing. So this is the infra that we have configured, and it won't take much time if I just click on create. So we have one VPC. In that we have 4 subnets, each like 2 for public and 2 for private. Then we have the route tables, and we will be going to see whatever the things would be pending for route tables. We will be going to configure it one by one. So for now, I'll just click on create VPC, and within few seconds, you will see that your services would be configured. So you can see that the route table internet gateway has been attached to the VPC. Now it is waiting for net gateways to activate. So we know that net gateways sometimes takes time. Then it will create the route table and associate the route table with the public subnets. So yeah, let's wait for it. We can see that all the services has been created. So we will just click on view VPC, and let's go to the things one by one. So I'll just select this VPC first. So I will filter out the services, which is project ECS VPC, and I will come here VPC. So we have the VPC, then we will go to the subnets. So I will just do this, okay? And let me refresh this first. Okay, now we can see that we have the public subnet and private. So let's see like how can we differentiate with the public subnets and private. So auto sign by public IPv4 in it's disabled. That's good. Now we have to understand we are route table as well. So I'll just go to the route tables, and we have the route table. So the first thing is the public route table. So let's see the route table. So in the routes, we have the internet gateway that is expected. Then in the subnet associations, I am expecting public subnets. So here are the public subnets. Now we have to validate for the private. But for the private route table, we have the private subnet 2. Then the route is for net gateway. That is awesome. And the same thing is for private subnet 1. And this is a private subnet 1. Okay. So route table is configured correctly. And also net gateway will also be configured as per my understanding. Yes. So we are good with the infra part. So what we will be going to do is that we will be going to start creating our services. So the first is always creating the RDS, because it takes a lot of time. So this would be our database. So we will be going to configure the RDS first after creating the VPCs and all other networking services. So here, before creating the RDS, we need to have a subnet groups. So I will click on subnet groups. So here you can see that we have already one subnet groups created, which is for default VPC. So I'll have to create a subnet group for my own VPC. I will keep the name is ECS DB subnet group and keep the same description here. Then I will select the VPC. So the VPC would be, let me get the ID first. So the ID is E41. So the second one is our VPC. Then after that, we have to provide the AZs. So let me check the AZs for the subnets. So I think we have two AZs only. So let me check the AZ, which is 1A, 1B. Okay, that's amazing. I'll just delete it and keep it to 1A, 1B. Now we have to make sure that we have to select the private subnets only. So our database won't be accessible outside of the network. So what I'll do, I'll just click on this. In the USTs one, I have private subnet 1, and the USTs 1B, we have the private subnet 2. After that, I'll click on create, and it is created. Now, once it is configured, we can create our RDS. So I'll click on create database. So I'll go with the full configurations, and we have to use we have to use MySQL, and that is simple MySQL that we need. We don't need Aurora one. After that, I'll be like, this is the engine version, so 8.4.7 is fine with us. And for now, I'll keep it free tier so we can reduce some costing as well for this project. And here I'll provide the name is ECS database 1. And this is a master username. So after that, I'll provide the password for our database. So I'll keep auto generate password. And once it will done, I'll be going to use this, which is T4G micro. That is a very minimum cost we will have once we will complete this project. Then for the allocated storage of 20 GB is fine. Even if you want, we can keep it to 10. And rest of the things would be as it is. We just need to go with the private. We just need to select the networking things like project ECS VPC. Then according to that, we have to select the subnet group. Now after database created, we can't change VPC. That is obviously an important thing. Now here, this is a security group and I don't want to use any default security group. So what I'll do, I'll click on create new. I'll provide the name is ECS RDS SG. Availability zone will be no preference. And later on, we will be going to modify the changes for our this security group. And this is it. And now we can click on create database. Okay. So you can see that the Amazon RDS free tier is available. So it won't incur a lot of cost, or maybe it will be a zero cost for me because I'm doing this for the second time. So I don't think so. It will take a lot of time for me. So yeah, meanwhile, it will be creating what we can do. We can just do the changes for our security groups. So I'll just go to EC2 section, and here we can find our security groups, and we are expecting ECS RDS security group. Okay. So first of all, outbound rules. Here we can see that all traffic allowed. That is amazing. Now inbound rules is very important because this is for us. Now one rule is already configured, so I can connect from my machine. But again, for that I need to be in the network. So what I'll do, I'll just delete this one and create new one. In that, I will have to provide the protocol. So the protocol would be MySQL. So it will be 3306 port range. After that, we have to provide the source. So instead of providing the source, what I'll do, I'll just provide the specific security group reference. So whatever the service will be attached to the particular security group, it will be going to allow those machines only or those services only to communicate with the MySQL. So what I'm trying to say here is that our backend needs to communicate with RDS. So for that, we need to have a security group for backend, and then backend security group we will attach with this in this source. Okay. So hope you understand, because the same thing we have done for two-tier architecture as well when we have deployed that. So for now, what I'll do, I'll just click simply go with the default security group. So this is a security group. So I'll just click on this default one, and also I will check once whether this is the default security group for our own VPC or it's a default VPC. So I'll just go to the security groups, and here we can see this is okay 4.1. Okay, this is a VPC, this is a VPC, so it's a 4.3.5. So yeah, this is the correct that this is a security group. So I'll click on save rules, and we have set up with our RDS cluster, like RDS security group. So let's see whether the RDS cluster is created or not. So I'll just refresh it, and it is coming up that I can say now. Like meanwhile it's creating, I would like to give you a brief over the about the applications. So we will go to our application. So here is our application, and so I would like to go with first backend. So this is our backend. Okay. So here we have the simple application that the application is doing CRUD operation. And the first thing, it will be going to authenticate with the RDS cluster or any databases. So for that, this is compatible with AWS itself. Like this code is dedicated for AWS because we are fetching the DB config from SSM parameters. So either you can use secrets manager or any other secrets manager tools like HashiCorp Vault. But for now, I'm using parameter store that has a zero cost when you are using non-advanced feature or standard parameter store tier service. So this will again cost us zero or nothing, that I can say. We will have four keys that will be going to create on parameter store. So the first would be host. So we need to provide the RDS endpoint. So it will be send the request to the host. Then we will have the user for the database. So we will have the user admin. Most of the time you need to create the separate or dedicated user in the DB because admin is very heavy user and it has a lot of privileges, like all privileges that I can say. Then we will have the password, and then we will have the name, which is a DB. So this will be the path. So we will have to replicate the same thing, and we just have to provide the values, whatever we will get from our things. So see, you can see successfully created database. Now we don't have password right now. So what I'll do, I'll just click on view connection details, and here is our master password, and then this is the endpoint. So what we will be going to do, we will just add these points right away. So I'll just copy the password here for time being, and this is my path. So the path would be slash my app slash db, and then we will have the keys. So again, I will just search for parameter store, and I will click on create parameter, and here is the name. After that, I will be going to keep it as a secure string. So it is a host name. So we have the host name as this, and I'll copy this and I'll keep this here. Okay. Then I will click on create parameter. Then I will select the new, which is user. So the user is admin, that as per my understanding. I'll keep this admin. After that, we have to provide the password. So first, let me get the endpoint, like path. I'll click on this and secure string, and then we will have the password, and this is the password we have. Then after that, I'll click on create parameter. Now the last thing is DB name. So the DB name here is school. So this is a school attendance application, like school portal something. So that's why I'll keep this here, and I'll remove this first. And this time I'll again keep it secure string, and the database name is school. and click on create parameter. So this is it. Like, we have done one of the important thing because it'll help us to authenticate with the RDS cluster or database. So this is it, and I'll just remove this password from here, and I'll keep it. I think we can keep it in the new file somewhere. So maybe we need it. So I was talking about the backend configuration. So this is the thing that will help us to fetch the DB configs from parameter store. Then we will have the things like it will create the database, so we don't have to create anything like tables and database. So it will do it automatically for the first time when it will be going to connect with the database. Or then we will have it will connect with the DB, then it will do the table creation, and after that it will have the health check. So the health check would be a slash health, then we will have the slash health slash DB. So if the connection would be successful, so we can see that the DB will also give us status 200. So this is our dedicated things that we have to do it. After that we have the route. So what are the things it needs to run? So whenever you're accessing it slash, so it will provide the search results from a student table. Then whenever you're doing the slash student, so it will do like get the query for student again. Then for teacher it will do the same thing for this. And for add operation, so it will have the add student, add teacher. Then it also have the delete, that will have the app dot delete, and like for the student and teacher for both. And then it will the restart the server. So yeah, that's it about the application. So I hope you understand about the backend application, how things will be working for us. Now the next thing that we have to start deploying the application, because we have set up most of the things for us. So as this is the Dockerized application, so we need to have one of the important thing, that is which is ECR, which is container registry, where our Docker images will be going to store. So for that, I will search for ECR, and here is our ECR repository. So currently we don't have any private repositories. So we will be going to create both repositories for frontend and backend. So first I will create for backend, and here we will have to provide the namespace and then repo name. So namespace means environment. So I'll keep its dev slash backend. Then after that, the rest of the things you can keep it as it is. If you want to have the scanning, so you can do the image scanning settings as well. But I don't want to do the scanning for now. So I'll click on create. Then after that, I'll create the same thing for frontend, and I'll click on create. So yeah, this is it. Now, the next thing that we have to do is we have to automate our application deployments. So as it's an end-to-end CI/CD DevOps ECS project, so we will be going to use GitHub Actions for this. And for that, I've created the workflow. Yeah, I don't want to waste a lot of time. So I'll explain you each and every line what exactly it's doing, so you will be able to understand. But I would like to say that try not to copy things, otherwise you won't understand things properly. But if you're not here for GitHub Actions, so I can say just go for it, no worries. Like, you can just simply do the things, you can just keep this thing, and at the end we're just building the Docker file and we're just pushing it side, right? So I'll just explain you the workflow, what exactly it's going to do. So the first thing, that we are keeping the name of our workflow, which is backend build and push, in which it is building, like it will building the code, and then we will push the Docker image what we build. Then it will be going to run on workflow dispatch. So this is the event that we are doing, and then we have the job. So we will have only one job, which is build push, and we are going to use Ubuntu latest, which is a GitHub hosted runner. And then we have the content permission is read, so it won't write anything. Then we will have few of the default configurations, so it will run the bash script, like bash commands. Then we have the working directory, because we will be going to run this workflow specifically for backend. So whatever the commands needs to be run, it will be going to run in backend folder. After that, it has the steps. So the first step, that it will be going to clone the repository. Once it will clone the repository, we will have to authenticate with AWS credentials, because we have to log into ECR. So this is the configurations, like we are doing authenticating with credentials with AWS. So how can we do that? So you just, like, there are two options. Either you can go with OIDC, which is Open ID Connect, or you can simply use AWS credentials. That is not best practices, I won't recommend, but For now, I've already used one OIDC for my personal project, so I don't want to create another OIDC. Like I can't create another OIDC, and I don't want to provide more privileges or more repositories in that OIDC. So what I'll be going to do, I'll just go to my repository, and you have to do a simple thing, that is secrets and variables. Here you will have the actions, and we have the AWS access key ID and secret ID. So feel free to keep the access ID and secret ID here and add the access keys and secret ID of your AWS account. And once you will complete this project, I would recommend you to remove it. For now, I'm just keeping it because there is no issues with that for me. So I've already created the access keys and secret access key. So this will help me to authenticate with AWS Cloud and in the region of UST one. After that, we will be going to log into ECR as the access key is there. So it will do the login easily. Once it will done, we will be going to simply do build and push. Now in the build, we are like in the build and push, we are building the project and pushing it all together. So the first thing that we are using, which is action, is Docker build push action. And that we are providing the context. So context means that you have to provide the Docker file path. So the path is backend where our Docker file present for our backend code. Once it will build the code, it needs to push. So to enable the push, we have to add the flag which is push colon true. And then we have to provide the tags, like what exactly the tag would be. So this would be the tag, and this is my account name and the ARN that you can say. So this is that, like this is the repository path for my backend repository. So slash dev slash backend, and the tag would be GitHub dot run hyphen number. So the run number of GitHub actions would be there. So it's not going to start from one. It will be going to start from maybe the left from the previous number that it was left last time. So maybe like if I just show you here, if you just click on actions, so here is the backend build and push. So currently we can see is the run number, like we can understand from here. So you can see the run number is hashtag 8. So when we will be going to build this project or run this workflow, it will be going to give run number is 9. So yeah, that is it. And after that, like this is a workflow. It's a simple workflow and it will be same for front end as well. I will show you the Docker file first. So this is the Docker file where we are using Node 80. It's a older version, but it is compatible to the application that we have written. Then we have the work directory. We are providing the packages. We are copying it. Then we are installing the dependencies first. So I prefer npm CI instead of npm install. Then we are copying the full application code. Then we have the another thing which is, as we are doing it for multi-staging to reduce the size of our image as well. Then we are installing few other things that is required for our application. This is the thing that we are doing it for security practices. So it is creating, like the application will be running as a non-root container, and then it will be going to copy this, and this is the user, and in the end the application will be running via CMD. So this is it. And what I'll be going to do, because there is nothing changes, so once you will make the changes, what you have to do, you just have to come here in the actions, and here is the backend build and push. I'll just click on run workflow, and you have to select the ECS hyphen deployment. Okay, and click on run workflow. That is it. So whatever the workflow and the code would be there, it will be going to get the code from ECS hyphen deployment instead of master. So if you select the master, there it won't work because there are few incompatibilities or code changes over there. Okay, so now we can see our workflow has been started, and let's see. So the first thing that it configured with the like checkout code is done, then it is also done the configure AWS. So it is able to authenticate with AWS, then it is also log into ECR, and it is also done the build and push. So we can see that our workflow is succeeded. And if I just check the thing, so this is the workflow and this is the build number column 9. So to validate whether our image has been pushed or not, I'll just go to ECR and I will go to the backend repository, and there we can see this one. So this is the image tags, and currently we can see this one. It's, I don't know, like earlier it was not there. Maybe there is some issues. So no worries. Now for now we can see that this is the image. So what we will be going to do, we will be going to create our ECS cluster before deploying the front end. So first we need to understand whether our backend is able to communicate with database or not. So this way we can enable the two-tier first. So let's go to the ECS cluster for what today we are here. So first thing first, we will be going to create a cluster, and I will click on create cluster. I will provide the ECS demo free tier. Apart from that, this is very important thing, infrastructure advanced. So you have to understand like how exactly you want to deploy your applications or containers. So currently I will be going to use with serverless, where you don't think about creating or managing servers. So you don't have to create your own EC2s. In Fargate, it will create the EC2s or any servers automatically, and you have to just deploy your container. So this is when you are using your own instances, that looks a very painful efforts where you have to managing your EC2s as well. But in Fargate, you don't have to pay any cost. It will be going to use things automatically, like whatever the resources and CPUs you will be providing a memory. So it will allocate the machines accordingly, and you have to pay as you go. So this will be Fargate only for now, and I'll click on create. If you want, you can also go with the hybrid model where you are not relying on AWS too much. So currently I'm keeping it Fargate only and click on create. And it won't take much time because it's just cluster is creating, not any machine is creating. So I will just click on refresh, and we can see that our cluster is created, and currently there is no task running, there is no container is there. So now you can understand from Kubernetes perspective that we have set up our Kubernetes cluster, but we did not deploy any applications. So how can we deploy our applications? So in ECS, whenever you have to deploy our applications, we have to create one thing, which is task definition. So you can hear in the left, we will have to provide the blueprint of the container, like what are the configurations it needs to have to deploy our container. So I will click on create new task definition, and either you can go with JSON files, JSON way, or you can simply go with manual way. So what I'll do, I'll just provide the task name is backend hyphen task definition, which is TD. And again, infrastructure requirement. So I'll keep it launch type as AWS Fargate. Then after that, we will have the operating system. So I'll keep the operating system as it is. Now task size, it is very important. So I'll, for now, our application needs zero point 0.5 CPU would be enough. And like if you have to handle a scaling, so you can think according to the requirement of your applications or according to the traffic. And for memory, I'll just keep it 0.5 GB. That would be compatible for myself as well, but it's saying incompatible with 5.5 CPUs. I'm keeping it 1 gigs. Then after that, we have to create the task role. Now, why do you need task role? So it will be able to communicate with other AWS services. So currently, if I just expand it, so I have already one ECS task execution role. If you don't have, you just need to click on create new role, and from here it will open this section, and you just need to create the things. But for now, I'll show you what are the permissions that I've provided. So I'll just open the IAM section. And here is the roles. And here just I need to search for task execution role. And there would be few permissions. So the first thing you have to understand is ECS execution task role policy. So you have seen EKS cluster rule kind of policies. So this is the same that it needs. So this is very basic policy whenever you are going to deploy your ECS clusters and task definitions in it. But if apart from that, if you need any AWS API service, if you want to call any AWS services from your code or somewhere else, so you need to provide more permissions. So I will explain you two more things. So the second thing is ECS container registry public full access, then it has the full access. Now this might not be needed, but the SSM full access, like we need it. Like I'm not going to say we need full access. I'm saying that we need SSM access, where you can keep it SSM read access. And why do we need it? Because we have the parameters that is stored on AWS parameter service. So our code needs to communicate with ECR with parameter stores to fetch all those credentials. So that's why we need to provide this. So make sure that you provided this permission. again, I'm saying that this might not be needed. So this is it. So this is the task execution role that we have created. After that, again, we have to provide the things like task placements and all those things. We don't have to provide anything. Here we have to provide the container name. So I'll keep the container name is backend. And after that, we have to provide the image exactly like as we are providing the blueprint of the container, but we need to provide the container image. So as we are using ECR, so I'll just simply go with browse ECR images. And here you just need to select this, and here you can see that there are two ECR, which is dev backend, dev frontend. I will be going to select dev backend. Then after that, I will be going to select this 9 image tag. And now this is the time where we have to map the ports. And this is very important thing that you have to take care of. In the port mappings, we have to provide our port that is on our application is running. So if I just show you my application, so our application is running on port 3500. So this is our container port. So I'll keep it 3500. Then in the container port, I'll keep it in the port name, I'll keep it backend port. And this is a protocol. That is it. After that, resource allocation limits, it is an exceeded limit. So if it's crossed the this thing, so it will also have the limits. If you want, you can like when you are doing in productions, you should do it. But rest like environment variables, we don't need it. We if we need any things environment from file, so we can store it here. The environment file can be hosted on a S3. So these kind of things we can do. Apart from that, we don't need to do anything. And health check, so if you want, you can configure health check. So it will also show you the health status in your for your services as well when we will be going to deploy our container in ECS clusters. But we don't need it for now. Now I'll click on create, and the task definition has been created. So now the blueprint has been created. Now from the blueprint, we will be going to create a service. So we will go to the clusters, and here it will be going to have the services and tasks. Now, what exactly it is? Because we have created the blueprint, but maybe you say that Aman, we have created the containers blueprint, so why it's not deploying it? Because service is the thing where you will be going to mention or give the details about your containers, how containers needs to be behave, like the design numbers of containers and other informations, like if you want to do the troubleshooting. So it is kind of a you're providing the replicas, number of replicas in that. So also it will be going to run the applications continuously, and it will also have the how can you access your applications. So there are a lot of configurations that you have to provide. So this is very very high level of task definitions you're providing, which is very basic, like CPU memory, then you're providing the image, then you're providing the ports and mapping. That's it. But now you have to talk about the networking thing as well in the for your container, like how will you be able to communicate with your container, how will you behave, like how the application needs to be behave when your application like number of replicas. So for that we have to create the services. So I'll click on create service, and first of all I need to select the task definition. So it will use this blueprint to deploy our containers, backend containers. Then this is a capacity provider strategy. So if you read this, that it is a compute options, like either you want to go with Fargate or Fargate Spot. So Fargate means that it will going to use is on-demand instances most of the time. But when you are going to use Fargate Spot instances, so it will have least cost. But again, for now, we will be going to keep it Fargate only. If you have dev environment, you can consider Fargate Spot because you can have the a limited number of interruptions when the application is not much critical. So it's fine for that. Apart from that, platform version, like it's fine. Now, the important thing is that troubleshooting configuration. So it is recommended. So what does it mean that let's suppose if something goes wrong with your container, so you want to go into that container, you might want to check some configurations, whether they are correct or not, whether they are present or not. So for that, we have to enable the turn on ECS exec, which is when we run Docker exec command to enter into the particular container. So if you want to do that, always check this box, and I would say 100% like you should enable this checkbox. Otherwise, there would be a lot of issues and you won't be able to understand. You will be just assuming from outside of the container that this might happen. After that, we will have the deployment configurations like rolling update. How will you things, how things works in that way. So here we have the desired task. So I'll keep it for now 2 because we have 2 AGs. Like I'm just keeping it for now. It depends if you want to do it or not. Then we have the availability zone rebalancing. So I'll keep it as it default. Then in the deployment options, there are multiple ways, like if you want to go with canary deployment strategy or blue green or linear or rolling update. For now, I'm keeping it rolling update, and default configurations is fine for me. Now, the next important thing is networking. So networking here, we have to make sure that we have to select the project ECS VPC, and then I will clear the subnet sections, and I will simply use. Then we have the service connect, service discovery, and like this is bit we don't need. But for load balancing, we need it because we want to communicate with our because our front end needs to be communicate with the backend. So either you can have the static IPs or domain on top of it load balancers. So it depends on you. But for now, I'm just keeping it application load balancer, and I'll be going to create one load balancer which is ECS ALB backend. Then I'll provide the listener. So the listener would be 80 for me. Then we have to create the target group. So this is a target ECSTG backend. And here I have to provide the port, which is 3500, as our container port is 3500. Then after that, this is a health check part. So as I've told you that our application health check is configured at /health. So I will keep it /health. Then apart from that, things are easy, and I just click on create. And as soon as I'll create it, so it will take now time because now it is configuring the servers, like the machine, and on that it will do some configurations, like installing a few things, and then it will be putting up all those things like required things to run a particular container. So it will take around 2 to 3 minutes, so wait for it and I'll see you there. So now we can see that our backend service has been created. So I'll just click on this, and this will show us the task that is running, and we can see that our target group is also healthy, so it is also running the task. And yes, we can see that our tasks are running. But now I wanted to check that whether our DB connection has been successful or not. So we can simply use the logs for that. So I'll just go to the log section, and here we can see that the table, that the server is running on port 3500, table is ready, database verified, connect to RDS. Now you will see the same thing again because we have two containers running, and that's why this is showing us. So it means that our backend is configured and it is able to communicate with database. Now we have to set up our front end. So for the front end, we have the applications, and like front end is a little bit mess because whenever you see there are a lot of index HTML files and CSS files we will be able to see. So I'll just keep it for home, like student.js and teacher.js. So this is the API that we have to provide. So it will be able to communicate to the backend. That's it. So I'll just simply jump onto the workflow for you. So this is the same thing that we are doing. Like we have the name, workflow dispatch. Then we have this configurations. We are building the Docker image for front end, and then we are pushing it. Now the one important that we are adding, which is the build argument. So we are providing this at a runtime. So it will be able to have the endpoint of it. So I have the endpoint, which is we have created using the load balancer. So I will just get it from here. And this is our endpoint. And you can see the DNS as well. So before that, I'll just go to the target group. As we already know that both the targets are healthy from the ECS itself. So we can also see from here. And this is our target group. So we need this load balancer DNS to communicate from front end to backend connection, right? So we have to provide this, and we are providing it using secrets. And as I have already shown you in the secret section, so we have to provide this one. I'll just copy this, and I will be adding this. So this is the workflow. So what I'll be going to do, I'll just go to there, and we'll go to the settings section, and here is the secrets actions. And here you can see API base URL. I'll just keep it this. And before that, just add HTTP. So it won't try to communicate on HTTPS. Otherwise, it will fail because we did not configure SSL for this. So I'll click on update secret. So now the API base URL has been updated. Now what I'll do, I'll just simply go to the code, or I'll just go to the action section, and we will have the front end build and push. And I'll just select the ECS hyphen deployment and run workflow. That is it. That is what we have to do right now. After that, I'll just refresh it and it is started running, and 99% it will be going to work fine. So our workflow is succeeded. So again, I'll go to the ECR registry and I will check the front end image section first. And yes, we can see 17 is there. And again, this is happened like earlier, it was not happening. I don't know what exactly the issue, but it's fine. I think we might have doing something. Uh, I think this is related to context that is giving us some issue, but it's fine. For now, what I'll be going to do, like we will have to create the task definition for this. So we will just go to the task definition for ECS, and here I will click on this and I'll provide the front end hyphen TD. Again, things would be similar at this time, and I will keep this zero point 0.5 and 1 GB. And this time I'll keep front end and I'll do the browse ECR searches. And this time we have front end and select this image. After that, the container port. So this time we have the container port and our application is running on port 80. So I'll select, provide the name is front end hyphen port. And apart from that, things would be as it is. And I'll click on create. So the task definition is created, and then we will be going to go to the cluster and we will create the service for our front end application as well. So this time I will select front end hyphen TD, and this is the task definition, which is 18 revision. After that, we will keep this same, and again, I'll open the troubleshooting configurations and desired applications I'll keep to. Then in the networking, I will keep ECS. So I would recommend you to always check this, because by default it takes a default VPC and you will be in the chaos if you don't check it, because as we have our different VPC. So this time I'll keep it public subnets, and the security group I'll keep it is default. Now let's come to the load balancer. I'll click on use load balancer. And here we have the things which is I'll provide ECS ALB frontend. Now, if you want, you can also use the same load balancer and just play with the listeners and route-based pathing in the load balancer. But for now, I just wanted to keep it simple. Otherwise, you will be confused if you haven't worked with the listeners and rules that you can create it for multiple services. So for now, I'm just keeping it this. And after that, this is a listener 80 and target group is ECSTG frontend. And here I will keep the health check is slash health. Then other things would be as it is, and I'll click on create. So again, it will take some time, as we know that service takes some time. But before that, like meanwhile it's creating, I'll show you the container execution, like how you can troubleshoot the containers if there is any issues coming up. Okay, so this is a task that is running, and you just have to click the task, and it's like a pod in Kubernetes. And what you have to do that you just need to you can just drop it down, and you just need to scroll down here and you will see the containers, number of containers. So this is the container running, and if you see this button which is connect, so whenever the connect button is enabled, it means that you have enabled the ECS exec that I was showing you for troubleshooting steps. So you just need to click on this, and it will like log into that task or container automatically. You don't have to do anything. It will just do it using the cloud shell, and it will be going to run this command. And also if you want, you can run it from your particular machine or from particular EC2 instance, but for that you need to be in that network. So what you can see here, you just need to click, this is the command it will be going to execute, and I will click on run. And it will take some time if you haven't used Cloud Shell. So like around few seconds it will take. Now here you can see that we are in the slash app directory, and we'll see the things that we have: the server.js, we have the package, JSON file, node modules, Docker file, and Docker file, NBP. Like as we have already copied multiple files, all files, so that's why it's taking it. It's using this. So if I just also want to check the applications running on, like where it is running on, so we can try to do this. So we can see that our application is running on 3500. If you want to check whether the application is working fine or not. So you can simply do one thing, which is check the health check from here, and you can see that yes, status okay, the service is backend, uptime is this. So that's how you can troubleshoot things like most of the time. But if there is any other issues, you can feel free to do whatever you want to do in this container. So this is what I wanted to show you. Now let's see the whether the front end services is deployed or not. I'll just go to the cluster, and it is started the front end service deployment. And here we are in the task, and it is okay. It's taking some time. No worries. Let's wait for it. So we can see that our container is started running, the first container. Okay, let's see the configuration and networking. And also let's see the health and checks. So currently there is no target health, no targets enabled for it. Like it takes some time. Uh, So now the second one is taking time, activating, and both are in running. So from here, health and metrics you can check, or else, or also we can check it from target groups. So we need to have one more target, which is front end. And here we can see this is also successful. That's amazing. So our application has been deployed, and let's try to access the application. So before that, I would like to check the logs. Like I know that front end logs won't be have correct logs. Like it won't have the logs that I wanted. Like most of the time, it will have the service boot up logs. That's it. So what we will do, we will just simply use this ALB front end, and I will just keep this HTTP only. So now it's not accessible, and we need to check because it is saying that try check the connection or checking the proxy and firewall. So I think we did not update the inbound rules for our default security group. So here is our VPC security groups, and I'll click on this, and by default it, yeah, see, you can see in the source the source is not correct. So what we will have to do is we just need to keep, like, we just need to delete this one, and I'll keep it all traffic for now because we just wanted to check for now, and I will keep it anywhere IPv4 and click on save rules. Once we will do that, so now we will be going to access our front-end application. So I'll just open this tab, and so here this is our application, and both are the things working fine. So what I'll do, I just try to add the record. So I'll keep the name as, and we'll try to save, and we can see that the addition operation is working fine. And if I just try to do the same thing here, so let me try to do that as well. And it is also working fine. If I try to delete, it is also working fine. So yes, like this is the application that is working fine. Now, if you want, you can also add the domain on top of it where you can map the load balancer with the domain. But for that, you have to make sure that the connection should be like from front end to back end needs to be HTTPS. So what I'm trying to say here, that whatever the API base we have added in the GitHub Actions, it should not be HTTP. Otherwise, you will get some error where as you're trying, like as your front end is HTTPS and trying to authenticate or trying to send something to HTTP or trying to connect with HTTP based application, so it won't work. So that's why if you are trying to do that, feel free to do that. But I'm just giving an overview that you can do. But for now, this is it. And we will be going to just do the cleanup part from here. And I don't want to waste your time on the cleanup part. So I have few things that I can share the things so you can take a snapshot or screenshot. So what are the things that you have to delete? So you just need to follow this, like follow the sequence to delete things one by one to avoid any extra costs. So first of all, we will be going to delete the ECS clusters, then we will be going to delete task definitions, and apart from that, load balancer, target groups, then RDS. So actually this we have to follow this chronological order. Otherwise things would be dependent to other services as well. So that's why you might not delete other services. So I would recommend you to delete the services like in this sequence so you won't get any issues at that moment. So yes, that is for today's video. I'll see you in the next one. And feel free to tag me over LinkedIn if you are sharing your learnings with community. So I would be happy to see. So yeah, thank you. Have a good day.